In this video, let's take a look at comparing slopes. So first we're going to write down the slope-intercept form of a line. So that's y equals mx plus b, where m is the slope and b is the y-intercept. So this says identify the slope given y equals 4x minus 8. So what's so nice about slope-intercept form is when it's in that form, you can just pick out the slope is the number in front of the x. So in this case, the slope would just be 4. And then when we need to identify the y-intercept, that's just the other number, the b value. So we'd say b equals negative 8, which is our y-intercept. Okay, so we have some examples comparing the slopes. So first example gives us f of x is negative 3/4 x minus 4. So our slope is just the number in front of the x for this one. So the slope would be negative 3/4. And that's the same thing as a decimal value of negative 0.75. So we might need either one to compare it in just a minute with the one on the graph. So it says g of x is graphed on the right. So they have already picked out 2 good points on the graph. And they're good points because they're sitting like right where the grid crosses at an exact value. That's what I mean by good points on a graph. And so it looks like it's at 5, but then we got to go down 1 box to get to the other point. So it falls 1, or like the rise is a negative 1. And then we've got to run 2 boxes to the right. So the slope of this graph is going to be rise over run. Remember, that's how we pick it out of a graph. And it's going to be negative 1/2. So when we come over here and compare the two, negative 1/2 is the same thing as negative 0.5. And sometimes it's hard to think of negative numbers, so it's good to think of your number line. The bigger number is going to be closer to 0. So if we think of a number line and we have 0 and we have negative 1, then in the middle is negative 0.5. But between negative 0.5 and negative 1 is negative 0.75. So it might look larger, but as a negative number, it's actually the smaller of the two, because your larger number is going to be closer to 0. So negative 0.5 or negative 1/2 is going to be the larger slope between these two. All right, let's look at example 2. Which function has the smallest slope? So let's pick out the slope from our table first. That's f of x. So remember, from a table, we want to look at change in y over the change in the x. So look at how the y values are changing. Negative 8 goes to negative 6. Negative 6 goes to negative 4. And negative 4 goes to negative 2. So it looks like they're adding 2 to each of these y values. That's what's happening to the y. And now look at the x value. So let's put m equals change in y is going to be positive 2 over the change in the x. So 0 to 5, 5 to 10, and 10 to 15. Each time on the x values, they're adding 5. So let's put 5 for the change in x. So this slope would be 2/5. And now let's compare that to the one on the graph. G of x is graphed. So this graph has a different scale than usual. Notice like this box over here is worth 2. So that means that every 2 boxes is worth 1. So I'm going to go ahead and add that to my y-axis. Like that would be 1 and that would be negative 1. And that is negative 1 and that is negative 2. And it's good to look at these sometimes because they don't always give you the same scale on a graph. So this is a good example. Now what I like to do is pick out 2 good points. And I see there's one right here in the middle because it's at an exact intersection of my graph. Then I see another one is over here. There's one right here that's at an exact intersection. And there's another one further over here. So like either that one or that one would work. So let's just go with the shorter distance. So if I've got to get from this first point, I've got to go up 1 unit. And then I've got to go over. And remember, actually I said 1 unit, but really in this scale, that's only a half. Because each box is not just worth 1 this time. So I got to be careful. So I go up half a unit. And I got to run 1, 2.5 units to the right. So what if I had used that other point? Would I get the same slope? And you definitely should get the same slope no matter which 2 points you use. So we could look at that. So I'm going to write this one down and then we'll look at that one. So our slope for this first option would be 1/2 divided by 2.5 because it's rise over run and it's positive. But now let's look at it from that other point's perspective and just see if we get the same value. So if I use the other 2 points, I'm going to use this one and this one. So we've got a rise 1 unit, but it's 2 boxes in this case. And then we got to run 1, 2, 3, 4, 5 units. Okay. To get all the way over there to that other good point. So then the slope would be 1/5. But notice that looks like a lot easier than dealing with these fractions and mixed numbers. So let's stick with 1/5 because that is better. Now we could simplify this. Let me back up to show you they do come out the same. So when we have a fraction divided by a mixed number, we would need to clean that up. So we'd have 1/2. And then 2.5 as an improper fraction, you've got to take the denominator of the fraction and multiply by the whole number and add the numerator. So like 2 times 2 plus 1 is 5. And that would be 5/2. But then you have a fraction divided by a fraction. So you got to take the first fraction. You remember, keep it, change it, flip it. So I got to keep the first fraction, change it to multiplying, and flip the second fraction. So I get 1/2 times 2/5, and that becomes like the 2's would cancel out, and I just have 1/5 left over. So they do come out the same. I didn't want you to think I'm just picking one out because they are the same slope. But now I want to compare the two. So I have the slope of 2/5 and the slope of 1/5. And they wanted to know which one is the smallest. So 1/5 would be smaller than 2/5 because that is just half the size. Okay, so let's look at another example. This should say 3, so let's make this example 3. In the problem below, who has the greatest rate of change or slope and who has the smallest rate of change or slope? Show your work and write out your solution. So it says, we have CJ, Holland, and Brandon. CJ's in the table, so let's start with picking it out of our table. So our slope is going to be the change in y over the change in x. So if I look at what's happening to the y values, 0 goes to 13, 13 goes to 26, and 26 goes to 39. So these look like we're adding 13. So our slope would be 13 over the change in x values. So 0 to 2, 2 to 4, and 4 to 6. We're adding 2. So 13 over 2, or we can make that as a decimal, and that would be 7.5. Excuse me, nope, that'd be 6.5. So 6.5 or 13 over 2 for CJ. Now, Holland is just y equals 6x. So that is slope-intercept form because it's the same thing as if you have 6x plus 0, and your slope is just right there in front of x, so you can just pick that right out, and that would be 6. And then let's look at Brandon on the graph over here. So for Brandon, we got to do the slope is going to be the rise over run between 2 good points. So I'm going to pick this first point at 0, 0, and it looks like there's another good point right here at 1, 7. And I've got to go up 7 units. And I've got to go right or run 1 unit. So the rise over run on my graph would be 7 over 1, which is the same thing as just 7 if we simplify that a little bit. So now, let's see. Who has the greatest rate of change? So that was Brandon. So let's write our thoughts here. Brandon has the greatest slope of 7. And then who has the smallest rate of change? So that ended up being Holland. So Holland has the smallest slope, and I'm just going to put a slash. That's also a good way to say rate of change for either one of those. It's just a little more to write, but it means the same thing. So Brandon has the greatest slope or rate of change of 7, and Holland has the smallest slope or rate of change of 6. Okay, so that's just a few examples of comparing slopes.